Good morning guys, my name is Mohammad Mudassir Ansari and I welcome you to the channel Bookworm. Today we'll be reading the book Sapiens. I won't be covering this book in one single stretch, so it'll be divided into a number of segments. The segments will be notified on the video thumbnail as part 1, 2, 3, 4 and so on and so forth. I'll try to go slowly with a constant pace with proper tone variation, and I hope you do like this audiobook. So without wasting any much time, let's start reading the book. So the book for today is Sapiens by Yuval Noah Harrari, and it's part 1, the cognitive revolution, and the chapter we are going to read is An Animal of No Significance. About 14 billion years ago, matter, energy, time and space came into being, into what is known as the Big Bang. The story of these fundamental features of a universe is called physics. About 300,000 years after their appearance, matter and energy started to coalesce into complex structures called atoms, which then combined into molecules. The story of atoms, molecules and their interactions is called chemistry. About 4 billion years ago, on a planet called Earth, certain molecules combined to form particularly large, intricate structures called organisms. The story of organism is called biology. About 70,000 years ago, organisms belonging to the species Homo sapiens started to form even more elaborate structures called cultures. The subsequent development of these human cultures is called history. 3 important revolutions shaped the course of history. The cognitive revolution kick-started history about 70,000 years ago. The agricultural revolution sped it up 12,000 years ago. The scientific revolution, which got underway only 500 years ago, may well end history and start something completely different. This book tells us the story of how these 3 revolutions have affected humans and their fellow organisms. There were humans long before there was history. Animals, much like modern humans, first appeared 2.5 million years ago. But for countless generations, they did not stand out from the myriad of other organisms that populated the planet. On a hike in East Africa 2 million years ago, you might well have encountered a familiar cast of human characters. Anxious mothers cuddling their babies and clutches of carefree children playing in the mud. Temperamental youths chafing against the dictates of society and weary elders who just wanted to be left in peace. Chest-thumping machos trying to impress the local beauties and wise old matriarchs who have already seen it all. These archaic humans loved, played, formed close relationships and competed for status and power. But so did chimpanzees, baboons and elephants. There was nothing special about humans. Nobody, least of all humans themselves, had any liking that their descendants would one day walk on moon, split an atom, feed in the genetic code and write history books. The most important thing to know about prehistoric humans is that they were insignificant animals with no more impact on the environment than gorillas, fireflies, or jellyfish. Biologists classify organisms into species. Animals are said to belong to the same species if they tend to mate with each other, giving birth to fertile offspring. Horses and donkeys have a recent common ancestor and share many physical traits, but they show little sexual interest into one another. They will mate if induced to do so, but their offspring, called mules, are sterile. Mutations in donkey DNA can therefore never cross over to horses or vice versa. The 2 types of animals are consequently considered 2 distinct species moving along separate evolutionary paths. By contrast, a bulldog and a spaniel may look very different, but they are members of the same species sharing the same DNA pool. They will happily mate and their puppies will grow up, pair off with other dogs and produce more puppies. Species that evolved from a common ancestor are bunched together under headings genus. Lions, tigers, leopards, and jaguars are different species within the genus Panthera. Biologists label organisms with a two-part Latin name, genus followed by species. Lions, for example, are called Panthera leo, the species Leo of the genus Panthera. Presumably, everyone reading this book is a Homo sapiens. The species Sapiens, that means wise, and genus is Homo, that means man. Genera in the turn are grouped into families such as cats and dogs and the elephants. All members of a family trace their lineage back to a founding matriarch or a patriarch. All cats, for example, from the smallest house kitten to the most ferocious lion, share a common feline ancestor who lived about 25 million years ago. Homo sapiens, too, belong to a family. This banal fact used to be one of history's most closely guarded secrets. Homo sapiens long preferred to view itself as a set apart from animals, and often who has no family, no cousin, and most importantly, no parents. But that's just not the case. Like it or not, we are members of a large and particularly noisy family called the great apes. Our nearest living relatives include chimpanzees, gorillas, and orangutans. The chimpanzees are the oldest. Just 6 million years ago, a single female ape had 2 daughters. One became the ancestor of all chimpanzees, and other is a grandmother. Skeleton in the closet. Homo sapiens has kept hidden an even more disturbing secret. Not only do we possess an abundance of uncivilized cousins, once upon a time we had quite a few brothers and sisters as well. We are used to thinking about ourselves as the only humans because for the last 10,000 years our species has indeed been the only human species around. Yet the real meaning of the word human is an animal belonging to the genus Homo. And there used to be many other species of this genus beside Homo sapiens. Moreover, as we shall see in the last chapter of this book, in the not so distant future, we might again have to contend with a non-sapiens human. To classify this point, I will often use the term sapiens to denote members of the species Homo sapiens, while reserving the term human to refer to all members of the genus Homo. Humans first evolved in East Africa about 2.5 million years ago from an earlier genus of apes called Australopithecus, which means southern ape. About 2 million years ago, some of the archaic men and women left their homeland to journey through and settle vast areas of North Africa, Europe, and Asia. Since survival in the snowy forest of northern Europe required different traits than those needed to stay alive in Indonesia's steaming jungle, human populations evolved in different directions. The result was several distinct species, to each of which scientists have assigned a pompous Latin name. Humans in Europe and Western Asia evolved into Homo neanderthalis, that means man from the Neander Valley, popularly referred to as Neanderthals. Neanderthals, bulkier and more muscular than sapiens, were all adapted to the cold climate of Ice Age Western Eurasia. The more eastern regions of Asia were populated by Homo erectus, that is the upright man, who survived there for close to 2 million years, making it the most durable Homo species ever. This record is unlikely to be broken even by our own species. It is doubtful whether Homo sapiens will still be around 1,000 years from now, so 2 million years is really out of our league. On the island of Java in Indonesia lived Homo solenis, man from the Solo Valley, who was suited to life in the tropics. On another Indonesian island, the small island of Flores, archaic humans underwent a process of dwarfing. Humans first reached Flores when the sea level was exceptionally low and the island was easily accessible from the mainland. When the sea rose again, some people were trapped on the island, which was poor in resources. Big people who need a lot of food died first. Smaller fellows survived much better. Over the generations, the people of Flores became dwarfs. This unique species, known by the scientists as Homo floresiensis, reached a maximum height of only 1 meter and weighed not more than 25 kilograms. They were nevertheless able to produce stone tools and even managed occasionally to hunt down some of the island's elephants, though to be fair, the elephants were a dwarf species as well. In 2010, another lost sibling was rescued from oblivion when the scientists excavating the Denisova cave in Siberia discovered a fossilized finger bone. Genetic analysis proved that the finger belonged to a previously unknown human species which was known as Homo denisova. Who knows how many lost relatives of ours are waiting to be discovered in other caves, on other islands, and in other climes. While other human beings were evolving in Europe and Asia, evolution in East Africa did not stop. The cradle of humanity continued to nurture numerous new species such as Homo rudolfensis, man from Lake Rudolph, Homo erector, that is a working man, and eventually our own species which we have immodestly known Homo sapiens, that is the wise man. The members of some of these species were massive and others were dwarfs. Some were fearsome hunters and other meek plant gatherers. Some lived only on a single island, while many roamed over continents. But all of them belonged to the genus Homo. They were all human beings. It's a common fallacy to envision these species as arranged in a straight line of descent, with Erector begetting Erectus, Erectus begetting the Neanderthals evolving into us. This linear model gives the mistaken impression that at any particular moment only one type of human inhabited the earth, and that all earlier species were merely older model of ourselves. The truth is that from about 2 million years ago, around 10,000 years ago, the world was home at one and the same time to several human species. And why not? Today, there are many species of bears, brown bears, black bears, grizzly bears, polar bears, etc. The earth was once walked by at least 6 species of man. It is our current exclusivity that not that multi-species past that's peculiar and perhaps incriminating. As we will shortly see, we, sapiens, have good reasons to repress the memory of our siblings. Chapter is The Cost of Thinking. Despite their many differences, all human species share several defining characteristics. Most notably, humans have extraordinarily large brains compared to other animals. Mammals weighing 60 kilograms have an average brain size of 200 cubic centimeters. The earliest men and women, that is 2.5 million years ago, had brains of about 600 cubic centimeters. Modern sapiens sport a brain averaging to 12,000 to 14,000 cubic centimeters. Neanderthal brains were even bigger. The evolution should select for larger brains may seem to us like a no-brainer. We are so enamored of our high intelligence that we assume that when it comes to cerebral power, more must be better. But if that was the case, the feline family would also have produced cats who could do calculus, and frogs would by now have launched their own space program. Why are giant brains so rare in animal kingdom? The fact is that a jumbo brain is a jumbo drain on the body. It's not easy to carry around, especially when encased into a massive skull, it is even harder to fuel. In Homo sapiens, the brain accounts for about 2 to 3% of the total body weight, but it consumes 25% of the total body energy when the body is at rest. In Homo sapiens, the brain accounts for about 2 to 3% of the total body weight, but it consumes 25% of the body's energy when the body is at rest. By comparison, the brains of other apes require only 8% of their rest time energy. Archaic humans paid for their large brain in two ways. Firstly, they spent more time in search of food, and secondly, their muscles atrophied. Like a government diverting money from defense to education, humans diverted energy from biceps to neurons. It's hardly a foregone conclusion that this is a good strategy for survival on the savannas. A chimpanzee can't win an argument with a Homo sapiens, but the ape can rip the man apart like a rag doll. Today, our big brains pay off nicely because we can produce cars and guns that enable us to move much faster than chimps and shoot them from a safe distance instead of wrestling. But cars and guns are a recent phenomena. For more than 2 million years, humans' neural network kept growing and growing, but apart from some flint knives and pointed sticks, humans had precious little to show for it. When they drove forward the evolution of the massive human brain during those 2 million years, what then drove forward the evolution of massive human brains during those 2 million years? Frankly, we don't know. Another singular human trait is the walk upright on two legs. Standing up, it's easier to scan the savanna for game or enemies, and arms that are unnecessary for locomotion are freed for other purposes like throwing stones or signaling. The more things these hands could do, the more successful their owners were. So evolutionary pressure brought about an increasing concentration of nerves and finely tuned muscles in the palms and fingers. As a result, humans can perform very intricate tasks with their hands. In particular, they can produce and use sophisticated tools. The first evidence for tool production dates from about 2.5 million years ago, and the manufacture and use of tools are the criteria by which archaeologists recognize humans. Yet walking upright has its downside. The skeleton of our primate ancestors developed from millions of years to support a creature that walked on all fours and had a relatively small head. Adjusting to an upright position was quite a challenge, especially when the scaffolding had to support an extra large cranium. Humankind paid for its lofty vision and industrious hand with backaches and stiff necks. Women paid extra. An upright gait required narrower hips, constricting the birth canal, and this just when babies' heads were getting bigger and bigger. Death in childbirth became a major hazard for human females. Women who gave birth earlier, when the infant's brain and head were still relatively small and supple, fared better and lived to have more children. Natural selection consequently favored earlier birth. And indeed, compared to other animals, humans are born prematurely when most of their vital items or systems are still underdeveloped. A colt can trot shortly after birth. A kitten leaves its mother to forage on its own when it is just a few weeks old. Human babies are helpless, dependent for many years on their elders for sustenance, protection, and education. This fact has contributed greatly both to humankind's extraordinary social abilities and to its unique social problems. Lone mothers could hardly forage enough food for their offspring and themselves with needy children in tow. Raising children required constant help from other family members and neighbors. It takes a tribe to raise a human. Evolution thus favored those capable of forming strong social ties. In addition, since humans are born underdeveloped, they can be educated and socialized to a far greater extent than any other animal. Most mammals emerge from the womb like a glazed earthenware emerging from a kiln. Any attempting at remolding will only scratch or break them. Humans emerge from the womb like molten glass from a furnace. They can be spun, stretched, shaped with a surprising degree of freedom. This is why today we can educate our children to become Christian or Buddhist, capitalist or socialist, warlike or peace-loving. We assume that a large brain, that the use of tools, superior learning abilities and complex social structures are huge advantages. It seems self-evident that these have made humankind the most powerful animal on earth. But humans enjoyed all of these advantages for a full 2 million years, during which they remained weak and marginal creatures. Thus, humans who lived a million years ago, despite their big brains and sharp stone tools, dwelt in constant fear of predators, rarely hunted large game, and subsisted mainly by gathering plants, scooping up insects, stalking small animals, and eating the carrion left behind by other more powerful carnivores. One of the most important uses of early stone tools was to crack open bones in order to get to the marrow. Some researchers believe that this was our original niche. Just as woodpeckers specialize in extracting insects from the trunk of trees, the first humans specialized in extracting marrow from the bones. Why marrow? Well, suppose you observe a pride of lion taken down and devour a giraffe. You wait patiently until they're done. But it's still not your turn, because first the hyenas and jackals, and you don't dare interfere with them. Scavenge the leftovers. Only then would you go and your band dare approach the carcass, look cautiously left and right, and dig into the edible tissue that remained. This is a key to understanding our history and psychology. Genus Homo's position in the food chain was, until quite recently, solidly in the middle. For millions of years, humans hunted small creatures and gathered what they could, all while being hunted by larger predators. It was 40,000 years ago that several species of man began to hunt large game on a regular basis, and only in the last 100,000 years, with the rise of Homo sapiens, the man jumped to the top of the food chain. The spectacular leap from the middle to the top had enormous consequences. Other animals at the top of the pyramid, such as lions and sharks, evolved into that position very gradually, over millions and millions of years. This enabled the ecosystem to develop checks and balances that prevent lions and sharks from wreaking too much havoc. As lions became deadlier, so gazelles evolved to run faster, hyenas to cooperate better, and rhinoceros to be more bad-tempered. In contrast, humankind ascended to the top so quickly that their ecosystem was not given time to adjust. Moreover, humans themselves failed to adjust. Most top predators of the planet are majestic creatures. Millions of years of domination have filled them with self-confidence. Sapiens, by contrast, is more like a banana republic dictator. Having so recently been on the underdogs of the savannah, we are full of fears and anxieties over our position, which make us doubtfully cruel and dangerous. Many historical calamities, from deadly wars to ecological catastrophes, has resulted from this over-hasty jump. A race of cooks. A significant step on the way to the top was the domestication of fire. Some human species may have made occasional use of fire as early as 800,000 years ago. By about 300,000 years ago, Homo erectus, Neanderthals, and the forefathers of Homo sapiens were using fire on a daily basis. Humans now had a dependable source of light and warmth, and a deadly weapon against prowling lions. Not long afterwards, humans may even have started deliberately to torch their neighborhoods. A carefully managed fire could turn impassable barren thickets into prime grasslands teeming with game. In addition, once the fire died down, Stone Age entrepreneurs could walk through the smoking remains and harvest charcoaled animals, nuts, and tubers. But the best thing fire did was to cook. Food that humans cannot digest in their natural forms, such as wheat, rice, potatoes, became staples of our diet, and all thanks to cooking. Fire not only changed food's chemistry, it changed its biology as well. Cooking killed germs and parasites that infested food. Humans also had as far easier time chewing and digesting old favorites such as fruits, nuts, insects, and carrion if they were cooked. Whereas chimpanzees spend 5 hours a day chewing raw food, a single hour suffices for people eating cooked food. The advent of cooking enabled humans to eat more kind of food, to devote less time to eating, and to make do with smaller teeth and shorter intestines. Some scholars believe that there is a direct link between the advent of cooking and shortening of the human intestinal tract and the growth of the human brain. Since long intestine and brain are both massive energy consumers, it is hard to have both. By shortening the intestine and decreasing their energy consumption, cooking inadvertently opened the way to jumbo brains of the Neanderthals and Sapiens. Fire also opened the first significant gulf between man and the other animals. The power of almost all animals depends on their bodies, the strength of their muscles, the size of their teeth, the breadth of their wings. Though they may harness wind and currents, they are unable to control these natural forces and are always constrained by their physical design. Eagles, for example, identify thermal columns rising from the ground, spread their giant wings, and allow the hot air to lift them upwards. Yet eagles cannot control the location of the columns, and their maximum carrying capacity is strictly proportional to their wingspan. When humans domesticated fire, they gained control of an obedient and potentially limitless force. Unlike eagles, humans could choose when and where to ignite a flame, and they were able to exploit fire for a number of tasks. Most importantly, the power of fire was not limited by the form, structure, or strength of the human body. A single woman with a flint or a fire stick could burn down an entire forest in a matter of hours. The domestication of fire was a sign of things to come. Our brothers, keepers. Despite the benefits of fire 150,000 years ago, humans were still marginal creatures. They could now scare away lions, warm themselves during cold nights, and burn down the occasional forest. Yet, counting all species together, there were still no more than perhaps 1 million humans living between Indonesian archipelago and Iberian Peninsula, a mere blip on the ecological radar. Our own species, Homo sapiens, was already present in the world stage, but so far it was just minding its own business in a corner of Africa. We don't know exactly where and when animals that can be classified as Homo sapiens first evolved from some earlier type of humans, but most scientists agree that 150,000 years ago, East Africa was populated by sapiens that looked just like us. If one of them turned up into Morten Morag, the local pathologist would notice nothing peculiar. Thanks to the blessings of fire, they had smaller teeth and jaws than their ancestors, whereas they had massive brains equal in size to ours. Scientists also agree that 70,000 years ago, sapiens from East Africa spread into the Arabian Peninsula, and from there, they quickly overran the entire Eurasian landmass. When Homo sapiens landed in Arabia, most of Eurasia was already settled by other humans. What happened to them? There are two conflicting theories out here. The interbreeding theory tells a story of attraction, sex, and mingling. As the African immigrants spread around the world, They bred with other human populations, and people today are the outcome of this interbreeding. For example, when sapiens reached Middle East and Europe, they encountered the Neanderthals. These humans were more muscular than sapiens and had larger brains and were better adapted to cold climates. They used tool and fire, were good hunters, and apparently looked and took care of the sick and infirm. Archaeologists have discovered the bones of Neanderthals who lived for many years with severe physical handicaps, evidence that they were cared for by their relatives. Neanderthals are often depicted in caricatures as the archetypal, brutish, and stupid cave people. But recent evidence has changed their image. According to the interbreeding theory, when sapiens spread into Neanderthal lands, sapiens bred with Neanderthals until the two populations merged. If this is the case, then today's Eurasians are not pure sapiens. They are a mixture of sapiens and Neanderthals. Similarly, when sapiens reached East Asia, they interbred with the local erectus. So the Chinese and Koreans are a mixture of sapiens and erectus. The opposing view, called replacement theory, tells a very different story, one of incompatibility, revolution, and perhaps even genocide. According to this theory, sapiens and other humans had different anatomies and most likely different mating habits and even body odors. They would have little sexual interest in one another, and even if Neanderthal Romeo and sapiens Juliet fell in love, they could not produce a fertile child because the genetic gulf separating the two populations was already unbridgeable. The two populations remained completely distinct, and when the Neanderthals died out or were killed off, their genes died with them. According to this view, sapiens replaced all the previous human population without merging with them. If that is the case, then the lineage of all contemporary human beings can be traced back exclusively to East Africa 70,000 years ago. We are all pure sapiens. A lot hinges on this debate. From an evolutionary perspective, 70,000 years is a relatively short interval. If the replacement theory is correct, all living humans have roughly the same genetic baggage and racial distinction among them are negligible. But if the interbreeding theory is right, there might well be genetic differences between Africans, Europeans, Asians that go back hundreds of thousands of years. This is political dynamite which could provide material for explosive radical theories. In recent decades, the replacement theory has been common wisdom in the field. It has firmer archaeological backing and was more politically correct. But that ended in 2010 when the result of a 4-year effort to map the Neanderthal genome was published. Genetics were able to collect enough intact Neanderthal DNA from the fossil to make a broad comparison between it and the DNA of contemporary humans. The results stunned the scientific community. It turned out that 1 to 4% of the unique human DNA of modern population in the Middle East and Europe is Neanderthal DNA. That is not a huge amount, but it's significant. A second shock came several months later when DNA extracted from fossilized finger from Denisova was mapped. The result proved that 6% of the unique human DNA of modern Milesians and the Aboriginal Australians is Denisovan DNA. If these results are valid, and it's important to keep in mind that further research is underway and may either reinforce or modify these conclusions, the interbreeders got at least some things right. But that doesn't mean that the replacement theory is completely wrong. Since Neanderthals and Denisovans contributed only a small amount of DNA to our present-day genome, it is impossible to speak of a merger between sapiens and other species of humans. Although differences between them were not large enough to completely prevent fertile intercourse, they were sufficient to make such contacts very rare. How then should we understand the biological relatedness of sapiens, Neanderthals, and Denisovans? Clearly, they were not completely different species like horses and donkeys. On the other hand, they were not different populations of the same species like bulldogs and spaniels. Biologically, reality is not black and white. There are also important gray areas. Even two species that evolved from a common ancestor, such as horses and donkeys, were at one time just two populations of the same species like bulldogs and spaniels. There must have been a point when two populations were already quite different from one another, but still capable on rare occasions of having sex and producing fertile offspring. Then another mutation served this last connecting thread, and they went their separate evolutionary ways. It seems that about 50,000 years ago, sapiens, Neanderthals, and Denisovans were at the borderline point. They were almost, but not quite, entirely different and separate species. As we shall see in the next chapter, sapiens were already very different from Neanderthals and Denisovans, not only in the genetic code and physical trait, but also in their cognitive and social abilities. Yet it appears it was still just possible on rare occasions for a sapien and a Neanderthal to produce a fertile offspring. So the population did not merge, but a few lucky Neanderthal genes did hitch a ride on the Sapien Express. It is unsettling and perhaps thrilling to think that we sapiens could at one time have sex with an animal from a different species and produce a children together. But if the Neanderthals, the Denisovans, and other human species didn't merge with sapiens, why did they vanish? One possibility is that Homo sapiens drove them to extinction. Imagine a sapiens band reaching a Balkan valley where Neanderthals had lived for hundreds of thousands of years. The newcomers began to hunt the deer and gather the nuts and berries that were the Neanderthals' traditional staples. Sapiens were more proficient hunters and gatherers, thanks to the better technology and superior social skill, so they multiplied and spread. The less resourceful Neanderthals found it increasingly difficult to feed themselves. The population dwindled and they slowly died out. Except perhaps for one or two members who joined the sapien neighborhood. Another possibility is that competition for resource flared up into violence and genocide. Tolerance is not a sapiens trademark. In modern times, a small difference in skin color, dialect, or religion has been enough to prompt one group of sapiens to set about exterminating another group. Would ancient sapiens have been more tolerant towards an entirely different human species? It may well be that when sapiens encountered Neanderthals, the result was the first and most significant ethnic cleansing campaign in history. Whichever way it happened, the Neanderthals pose one of the history's great what-ifs. Imagine how things might have turned out had the Neanderthals or Denisovans survived alongside Homo sapiens. What kind of cultures, societies, and political structures would have emerged in a world where several different human species coexisted? How, for example, would religions, faith have unfolded? Would the book of Genesis have declared that Neanderthals descended from Adam and Eve? Would Jesus have died for the sins of Denisovans? And would the Quran have reserved seats in heaven for all righteous humans? Whatever their species, would Neanderthals have been able to serve in the Roman legions or in the sprawling bureaucracy of imperial China? Would the American Declaration of Independence hold a self-evident truth that all members of the genus Homo are created equal? Would Karl Marx have urged workers of all species to unite? Over the past 10,000 years, Homo sapiens has grown so accustomed to being the only human species that it is hard for us to conceive of any other possibility. Our lack of brothers and sisters make it easier to imagine that we are the epitome of creation and that a chasm separates us from the rest of animal kingdom. When Charles Darwin indicated that Homo sapiens were just another kind of animal, people were outraged. Even today, many refuse to believe it. Had the Neanderthal survived, would we still imagine ourselves to be a creature apart? Perhaps this is exactly why our ancestors wiped out Neanderthals. They were too familiar to ignore, but too different to tolerate. Whether sapiens are to blame or not, no sooner had they arrived at a new location than the native population began extinct. The last remains of Homo solonensis are dated back to about 50,000 years ago. Homo denisova disappeared shortly thereafter. Neanderthals made their extent roughly 30,000 years ago. The last dwarf-like humans vanished from the Flores Island about 12,000 years ago. They left behind some bones, some tools, a few genes in our DNA, and a lot of unanswered questions. They also left behind us, Homo sapiens, the last human species. What was the sapiens' secret of success? How did we manage to settle so rapidly in so many distant and ecologically different habitats? How did we push all other human species into oblivion? Why couldn't even the strong, brainy, cold-proof Neanderthals survive our onslaught? The debate continues to rage. The most likely answer is the very thing that makes the debate possible. Homo sapiens conquered the world thanks, above all, its unique language. So that's pretty much it for the first chapter of Sapiens. Please like, share and subscribe the channel for more amazing content, and I apologize for any mispronunciation and misspelling that I might have made during my narration. And the subsequent part of the audiobook of Sapiens will be covered in my upcoming videos, so please do subscribe for more amazing content. Till then, I'll take my leave and I'll see you next time. Thank you all and I love you. Thank you so much.